My name is Neil. I work for Healthcare Components Group, RPI. We're a part of Healthcare Components Group. And today we're going to be talking about the Midmark M9 and M11 sterilizer. Now, we are a little bit short on time, so I'm going to kind of do this a little bit out of sequence. Bear with me. We'll get to all the bits and pieces. The first thing I'm going to do is turn the sterilizer on because it takes 20 minutes to warm up. And since we only have an hour, I kind of want to get that going quick. Okay, so that bit of business is taken care of. Today we're going to be talking about sterilizers, steam sterilizers in particular. Some of this stuff will apply to other kind of sterilization, but we're also going to be talking about the history of sterilization and how machines have come along over the years and developed and moved forward. And we're also probably going to talk a little bit about bulk sterilizers as well. So let's get started. I am a visual, I like to play with things. Engineers, we do these things. So I have some gizmos that I'm going to pass around to you guys. This is the valve assembly to this particular machine. There's a tool, and I'd like to kind of, anybody that's interested, feel free to take it apart, look at the bits and pieces. Then nothing intimidating here. So this is one of the main components in this particular machine. Sir, if you don't mind, just send that with it, please. Okie dokie. So where are we today? Okay, so what are we talking about? We're talking about steam sterilization. And basically, what do we need to do sterilization? Well, in this case, we need to reach some specific temperatures. There's this thing called Boyle's Law, and you need to develop enough pressure to reach the temperature in Boyle's Law. We also need to have that temperature and pressure for a specific amount of time. What normally is done is we want to have a 100% kill rate, but when they set the programming up for these machines, they usually set them up as a 300%. So even if you were get a little bit shorter on the time, it still is doing the jobs of sterilization. Okay, so we're talking about steam and the condition of steam within a vessel. Now, it doesn't matter what size vessel this is, where the heater is, or why you're heating it. We have two conditions that steam can be in. One is, whoops, that's the wrong button, Neil. There we go. One is saturated. Saturated means that we still have water in the bottom, but we've actually built up enough steam to do our job, and that steam is being constantly recirculated within this closed container back into water, back into steam, back into water, back into steam. If we run out of water, we reach this situation where we have steam contained within the container, no more water in the bottom, and this can be superheated. And I don't know if anybody's familiar with it. You can use superheated steam to do things like cut steel. So this kind of condition we don't ever want to have happen inside of a sterilizer, but as soon as this kind of condition occurs, you immediately overheat because the machine can't deal with that kind of temperature. Okay. So there's that old law, Boyle's Law again. Yeah, I know we are here in California. This will apply to everywhere in California, but if I were in Denver, Colorado, I would have to tell those folks, whoops, I would have to tell those folks, stop that, oh, there we go, stop that, that this law does not apply to them because it's based on atmospheric pressure, and at high altitude you have to make an adjustment to these numbers. But this is what we want the machine to do. And in the case of the Midmark sterilizer, we're in about this range here. We want to go to 270 degrees and at least 27 to 28 PSI. That's what's built into the machine. If we go up above 275 degrees in the machine, it overheats. If we go above 30 PSI, it will also overpressure, and there are error codes for those things in this particular style machine. Okay, so even though we know that when we started out with that saturated steam, this system works, but it's not very efficient. what actually happens is that the steam will condense around the top of the chamber, it will thin out, and you'll wind up with denser steam at the bottom as it recondenses back into water again. What we want is to be able to circulate the steam around whatever we have in the machine to keep that uniformity in the steam while we still have a puddle of water in the bottom. So this is what we have, this is what we want. How do we get it? Well, somebody smarter than I developed this thing. This is called a bellows. And in the very oldest machines, simplest machines, you will find something that looks kind of like this. What are we talking about here? Well, in this first version, you have two chambers, and those are actually folds in a metal plate. And within those chambers, you have a fluid. And when that fluid reaches the boiling point of water, it expands, pushing this rod into this space and sealing off the bellows until it closes, until it reopens below the boiling point of water, until it cools. So this was the original style. And somebody realized that, boy, you're taking those two plates, you're stretching them out a lot. There's a lot of metal fatigue here. Maybe that wasn't the smartest idea. So they came up with this, which is a kind of a upgrade. It has 7 plates, and each one of those plates works exactly the same, but each plate stretches out a little bit less, so there's less stress on the entire assembly, and because it stretches out a little bit less, this is actually a more accurate system. You can get a finer temperature control with it, and that would be an upgrade. Then somebody decided this system was wrong, and they came out with an actual steam trap. Now, this particular device gets away from that fluid by putting a plug of a wax, and that wax has a known expansion coefficient, and as it's heated, it presses this bar into an opening, sealing it off until the whole device cools below the boiling point of water. So that's the latest version of a steam trap. Okay, so we're talking about machines and the history of these machines. And one thing I meant to say before is I answer questions for a living. Please, if anybody has any questions, shout out, stop me immediately. So, okay, this is kind of where we started from. This is the simplest version of what we consider a sterilizer. This is the Midmark M7. And what we have going on here, what we have going on here is we have a reservoir filled with water, as we talked about, a place where we can get water from. We have one single valve that allows us to let water into this chamber. There's a door, of course, that's not illustrated, into this chamber. Inside of this chamber, there's a heating element. We're going to shut the door with a gasket. We're going to heat that water. It's going to circulate inside around here. And when we're finished, the amount of time that we want this machine to sterilize, we're going to reopen this valve again. All the steam is going to flow out of the bottom of the chamber, back into the reservoir, where it's going to be recondensed into water again. This is reuses the water in the system to cool the steam. It's more economical on water. It's a little bit easier for the users. Okay, so so the other problem that we have in this is, again, you have a chamber, you have water in the bottom of it, you need to circulate the steam, so we needed one of those bellows that we were talking about before. And the bellows sits right here outside of the reservoir. It takes the steam from the top of the chamber, which is below the boiling point of water, and lets that back into the reservoir. As soon as this whole chain reaches the boiling point of water, that device seals off and you've recirculated the steam. Again, this is the oldest system. Then somebody got creative and they came up with this guy. This is the valve system to a Pelton crane Omniclave. A unique bit of engineering. What we have here are 2 valves built into a manifold. Those valves are controlled by a cam. So somebody has to turn this cam to move the device from one step of the process to the next step, filling, sterilization, venting, that sort of thing. And the other thing that I think makes this device particularly intriguing is it's got these 3 sets of switches in it, which are mounted right here. So this is the only device I can think of that has 2 different water paths and 120 volts electricity right next to each other. It's really great design. Works really well, real compact, scares me sometimes. Again, steam in, steam out, switches, cam to move it. This is a manual sterilizer. Somebody has to do that. What did we go to next? So we decided, somebody decided, that that was too complicated. It required technicians' time. We wanted to automate this whole process. So what do we need to do? We need to determine what a sterilizer actually does and how we can take advantage of things like microprocessors. I'm not going to read through these slides. They detail why the automatic machines are better than the manual machines, and everybody, I believe, has a copy of the program. Read at your leisure. So what do we need for a microprocessor controlled machine? We need to have certain inputs and certain outputs. Good, we're doing good. We have to have probes to measure temperature, pressure, the water level in the machine so we don't dry it out. We have to make sure it doesn't overheat and set itself on fire, and we better be able to have some sort of control from the guy using the machine. What do we want to get out of these machines? Well, we have to be told if there's an alarm. We want to know what the machine is doing, how it's doing it, how it's getting the water in and out, and if possible, get some results so you have record keeping of what that machine actually did. Now, this guy down here, results to external printer, is kind of in development because a lot of machines, instead of an external printer, they use a data logger, an external system that puts the cycle information onto a memory stick or memory disk of some sort, and it's usually loaded somewhere like a Google Doc or somewhere on the cloud, and that's where your record keeping is. No more little pieces of paper. Okay, so after the total success of this guy and the scariness of it, the manufacturers said, okay, in an automatic machine, we can do the same thing with 2 valves mounted on a manifold. And as that one, once it gets around everybody, that's what you're looking at. So what do you got here? You got a valve on the, whoops, you got a valve on the right-hand side that lets the water into the machine, into the chamber. That's a normally closed valve. When you want to let water into the chamber, you have to activate it and let the water in. As soon as you deactivate it, it stops the flow of water, and you don't need to worry about that being electrified. On the other side, this guy is a normally open valve, and when we want to start building up pressure within the chamber, we have to electrically close this valve, and that will allow the pressure to build up. That, in that case, in that way, if something happens to the electricity in this machine, this valve will automatically drop and you will never leave pressure in the chamber, supposedly. More on that later. But that's why this is a normally open valve, so that this machine cannot lock up like that. Okay, so what are we talking about here? Well, this is the Midmark sterilizer, and over the years, they have come out with 2 different versions of this machine. Now, at RPI, Healthcare and Components, we would refer to these as an older style, that's the -001 through 019, and a newer style, the -20, 22, 33, and 34s. The parts for this style machine and the parts for this style machine are not in all cases interchangeable, and we're going to talk about some of those. Right now, we just call this a red display, this a green display. If anybody calls me and I confuse you, that's what I was talking about, all the red display or the green display. Okay, so we've been running this machine, And I did that because it takes some time to heat up. And I don't know if anybody's heard, it's made a couple of hissing sounds. Boy, that'll drive new technicians crazy. They start the machine and a little while it makes that kind of hissing sound and they go, oh my God, my machine is doing something crazy. What the hell's wrong with it? Why is it doing that? It does it 3 times automatically. So what are we talking about in running this machine? Well, while I was talking, the machine went through phase 1, which is the filling process. We let water out of the reservoir by opening the fill solenoid into the chamber. Now in the back of the chamber, there is a water level sensor. And when that water level sensor becomes conductive to case ground, the valve is closed because there is enough water within the chamber to complete a cycle. Okay, then while I was talking, I turned the machine automatically went from filling to heating. And during the heat up process, we want to be able to get rid of as much air out of the chamber as possible. So we allow the steam to develop. That steam, as it develops, forces the cold air top of the chamber out through this valve, out through this solenoid, I'm sorry, that's a T, out through this solenoid, back into the reservoir, where if it is steam, it can be reconverted into water again. So during the heat up phase, we open this valve 3 times, that's the hissing sound you hear, and allow the steam to escape for a short period of time, taking the cold air with it. Okay, so we are still in the heat up phase. So we still have a couple of more minutes left till we actually get to sterilizing. But once we do get to the point that we have reached the proper temperature and pressure, there is on the main control board a pressure transducer that keeps an eye to make sure that the machine stays at the proper temperature, proper pressure. There is also a temperature sensor mounted in the back of the wall of the chamber to measure the temperature as the machine is going on. So we're going to leave it right there for a minute till we can get the machine caught up to the talk. But one thing I kind of like demonstrating, because it gets a little boring sometimes doing this all the time, your customers are actually asked to release the safety valve occasionally. So this is what it sounds like. It's lots of fun. I do that. Hey, stop that. Now I'll stop in a second. They are told to do that. It wears the safety relief valve out, and over time, they can occasionally need to be replaced. So that's something that I think people don't often think about, and that gets into the troubleshooting part when we get to there. Okay, well, you know what? We're just gonna outrun the machine. So after it's been running for a certain period of time, it will then go to do the venting phase. And what we want during the venting is we want to take the steam that's remaining within the pressure vessel. We're going to open up the valve that's on the vent side, and we're going to allow that steam to force all the water that's remaining within the reservoir back through out into all the water that's left in the pressure vessel through the valve back into the reservoir, where it's recondensed into water again for the next cycle. Okay, there we go. And between this cycle and the next cycle, we would want to wait 10 to 15 minutes to let the machine cool off. That's important. Okay, so we're going to go on to the technical side of the presentation because the machine is lagging behind us and we're almost halfway through here. Any questions? Cool. Okay, so basically what we're going to do is kind of organize the machine. We've drained the water, we've turned the machine on its left-hand side so the reservoir is down, and we've removed the trap door on the bottom of the machine, and this is what we can see. And we're going to do that a couple of different orientations and talk about each of these areas. So first one, when you're working under the machine, for any reason, take a look at what you got going on under here. You might find that there are leaks around these gaskets where the heating element goes through the wall of the chamber. There's also wires that can become oxidized and start to become brittle or frail. We want to keep an eye on that. If you do see that, there are washers that can be replaced. Also, while we're down here, we're going to take a look at these devices. These are the over temperature switches. When these devices open up, that machine knows that it's gotten too hot and it will automatically put out an error code. Now, in the older machines, the red display machine, though this device would completely turn the machine off. Your customer says, oh my God, my machine stopped. I don't know why. Midmarks don't put power switches in the machine. What happened? Well, the over temperature switch in the -001 through 19 opened up. It's in line with the hot line coming into the machine, and it just shuts the machine down. In this case, it's much more politer. Instead of shutting the machine down, it gives you an error code, at least something you can find. Okay, tech tip number 4. While you're looking at there, a lot of people don't actually think about this fitting. This is that fitting that takes the water in and the steam out. If that starts to loosen up or starts to get a small leak to it, you'll develop all kinds of buildup on it. Make sure that it isn't there while you're in the neighborhood. Okay, so we've tipped the machine back up into the position you can see it now, and we've taken the side off and we're going to look at the inside of the machine. Okay, so what are we going to talk about here? Well, on this particular machine, there's no real calibration to this circuit board. Basically, it works or it doesn't work. There are no potentiometers, nothing to control. It either works or it doesn't work. But there are some things on the older machine, the -01 through 19, that you can actually do. You can calibrate the 01 through 19 board. And on both of these machines, it is possible, as we describe here, to put an external pressure gauge onto this piece of tubing here, just to verify if you want that the machine is telling you the truth. But on these machines, it's not totally necessary. Also, while we're in the neighborhood talking about this piece of tubing, this piece of tubing is really, really important. It connects the chamber to the pressure transducer, and it has tie wraps at either end of it. There's a bit of copper here and a fitting, and there are tie wraps at either end of that piece of tubing. If those tie wraps fail or loosen up, you will get a lot of spurious error codes, pressure codes that don't make any sense, temperature codes that really shouldn't be like that. You need to have those tie wraps in place, and they need to be specialized tie wraps. Tie wraps come in different versions. In this case, we want to use either a red tie wrap or a blue tie wrap because they are high temperature. And since steam is coming down this line and this gets a little warm, we want to make sure that those tie wraps don't fail due to heat or expand due to heat or slip. We want those to be good and tight. Okay. So let's talk about boards. One of the big failures of this machine is the circuit boards. That RPI has a refurbishment for these. I can't lie to you, it wasn't a good design. There's nothing we can do to change it, but there are refurbished boards available. Now, when you are talking about these boards, if you've got this newer style board and this newer style machine with the green liquid crystal display, this board is exchanged mounted on its mounting bracket, because there are a number of different brackets that Midmark used. Please, if you need one, we need the bracket with it. On the older style board, that's this guy here, we don't worry about the bracket. They all look exactly the same. You just send us the board and we take care of it. On this older style machine, mounted behind this bracket is behind this board is a metal bracket, kind of like the other one, but the bracket stays in the machine. Now, when Midmark designed this -001 through 19 version, they did not put in a ground path between this board and the machine. What they did was they put a screw right, I think, in that corner. It's a black oxide screw. It goes through the board, picks up the ground, goes into the metal bracket mounted behind the board, goes down to the bottom of the case where there are 2 additional bolts, and then to case ground. What happens is that bracket, where it goes to the bottom of the case, tends to build up rust. And over time, that rust will actually break the ground path to this circuit board. So if you do have one of those -01 through 19 boards and you're thinking you might need to replace this circuit board, pull the circuit board out, pull the bracket out, turn the bracket over, look at the bottom of it. If there's any rust on it at all, clean the rust off. Clean the rust off the bottom of the machine, put the whole darn thing back together, and in a good chunk of the time, your problem might actually go away. So it's a good diagnostic step, even though it doesn't work every time. You do want to have a good ground to the circuit board. Okay, tip number 4, blown fuses. Oh, I'm sorry, but any indication of blown fuses, more times than not, are going to wind up being a bad board. But there are a couple of things that may cause the fuse to blow. We mentioned them, such as the heating element, the coils in the valves, or the door motor or pulse solenoid, which is used to open the door. You might check those to be sure they are still electrically not shorted before you replace a board that has a blown fuse. Okie dokie. So, we're talking about the valve assembly. Kind of touched on that earlier. One side's the fill, one side's the vent. We do sell rebuild kits. This guy on the bottom here, I particularly find intriguing. Oh, first of all, the tool. When I passed the valve block down amongst the tables, there was a tool with it, and it's used to open up these cases on these valves. Please, this is important. Do not use a pair of pliers on them. Any valve that you see that looks like this, don't crimp that sheet, that cover, that fluted cover, the bonnet. It doesn't take much to make it off round, and it's very, very hard to diagnose that without just plain replacing it. Also, while you're working on these, don't just assume that the problem is the piston part. Take a look at the sealing surface. Make sure that both parts are being replaced, or at least that both parts look good. Okay, valves. So Midmark used a series of valves. The first valves they used were, well, first of all, they're all 120 volts AC driven. And when Midmark went to Kip Norgren, they the first valves they made were AC driven and had something called a shading ring in them. A shading ring allows you to run a valve on AC by absorbing that little spot where the AC crosses the 0 line, going from plus to minus. That shading ring keeps a little bit of magnetism in there so the valve doesn't snap up and down 60 times per second. right? Keeps a little bit of magnetism, so it stays relatively quiet, but it tends to get hot. So they realized that another way they could go about doing that was, instead of just applying straight 120 volts to these valves, they built a full wave bridge rectifier into the coil of the valve. And what that does is it takes the AC, clips it off, so you're kind of looking at pre-smooth DC, which takes some of the buzz out of the valve and takes the heat out of the valve, because it isn't bouncing up and down 60 times a second. The parts for a valve that is full wave bridge rectified versus the parts for a valve that is not full wave bridge rectified are not interchangeable. So it's always a good idea to know which kind of valves you got. If you do mix that up, your valve will buzz. That's not the worst thing in the world, but it's really annoying. Also, one thing we don't illustrate here is that Midmark of later years went to a separate manufacturer for these valves. They went to a company called Solenoid Solutions. Solenoid solution valves are not interchangeable with Norgren valves. We don't currently support them. The way you can tell whether you've got a Kip Norgren valve or a solenoid solution valve, the Kip Norgren valves are in this in this silver canister. It's round. On the solenoid solution valves, they are black, they are square, and they have exposed coils. Also in the solenoid solution valves, they have a separate box that goes between the circuit board, never mind, that goes between the circuit board and the valve itself. That box has a full wave bridge rectifier in it. If you ever were to decide to go from a solenoid solution valve to a Kip Norgren valve, you would take that block and you would throw it away. You can't put a full wave bridge rectifier on a full wave bridge rectifier. It will not work. Cool. Okay. So there are, this kind of tip was pointing out that there are an additional style of these machines. There's a machine that is called a D machine that does not have a door motor or a pulse solenoid. Somebody has to manually open the door. Why they called it a D machine, I guess it's because it's D, it's not a active machine. So there is a version that you have to open the door on, and there is a tip here about the door motor which comes on this. There are 2 holes, and they are dependent on the size of the machine. So you just need to be sure, if you do replace the door motor, that you get it in the right hole. There's a bar that runs it. That's what that's about. Okay, so now we've opened the door and we're looking at the inside of the door, and here are the seals that are involved. There's a round door gasket, and there's also a half moon dam gasket. They should be replaced yearly. They are done as part of the preventative maintenance. Now, in a Midmark system, there is a wire that's installed inside of this door gasket. If you do use an RPI or healthcare components door gasket, you need to take that wire out. Our door gaskets are not designed to use the wire. We have no need for the wire. If Midmark still feels they need to have a wire, great for them. We don't need one. Yeah, it'll mess these gaskets up big time. I know that. Yes. I think I did your call. Okay, let's see. You should clean the race that this is the door race where the door gasket goes. Make sure everything's nice and clean in there. Cleaning products. We're going to be talking about cleaning products quite a bit in the next couple of slides. You never want to use anything in a sterilizer that smells like bleach. You don't want to use things like Comet or any of those other cleaners. The best thing that you can use is the cleaner that is made for the machine, But if you need to use something else, buy some real stainless steel cleaner like you'd use on your refrigerator or your appliances that doesn't smell like chlorine and is specifically designed for stainless steel. So when we get this door gasket out and the dam gasket, we're going to clean behind them. Usually you can just do that with a Scotch-Brite pad and some water. If it needs anything else, you can go further. Okay, so over the years, we have kind of found this to be an odd issue. When you have a door that is hinged on one side and latched on the other side, the amount of pressure that's applied to that door panel is slightly different on the left than on the right. Now, within this door panel assembly, right behind this metal plate, is a piece of insulation, the entire size of that metal plate. And it's designed to keep this piece of plastic from getting too hot. Now, it does get hot anyway, but it would be a lot hotter if that insulation pad wasn't in there. And what we have found over time is because there's this differential pressure on either side, that pad will fail. Now, there are a couple of things that you can do to kind of tease that information out without actually going and pulling it out. If you go to a customer and they say, you know what, I put a door gasket in, it's just not working right, I don't get it, what do we do? Well, the first thing you can do is you can take this door gasket out and rotate it 90 degrees just to see if it's worn differentially because of this problem. If that seals it up, okay, we're getting suspicious about that pad. Once you've determined if you want to take it apart, you have to take the door panel off. There's a nut on the underside of this assembly. There's a bolt on the back right about where that pointer is. You take the whole thing out, and what you'll find is that pad will be cracked about, I don't know, maybe a ½ inch or inch around that center stem. One side will be cracked, one side won't be cracked. And that's why your door would refuse to seal. Go away. Okay, replaced yearly, there is a spring that's used to pop open the door. You are never going to do that, are you? There's a spring that's used to pop open the door, and if you find that it is weak or not getting the door where you want it to be, it can be doubled up. We put 2 of them in the planned maintenance kit. Also, this picture points it down. It can also be turned 90 degrees sideways to even get more force out of it. But these are part of the planned maintenance, and that's why we give you 2 of them, just in case you don't like it. Okay, so water quality. Okay.
Right.
Of course. Yeah.
So on your website, you talk about 2 different PM kits for the M9 specifically.
Uh-huh.
About one that has a metal flap.
Absolutely, absolutely.
So are there many that have the metal flap in circulation?
Not as many as you would think. There are very, very few. You may never see one. Okay, but right. What? Just so I can give you a description of what we're actually talking about here. What would happen is there's a right angle bracket welded to this piece of metal, and it hangs about like that. Okay, you can see it as soon as you open the door. It's not really hidden, but most people have never seen it before because it was the very, 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 very oldest machines. They realized, I guess, that just wasn't really efficient. Just for anybody that doesn't know, in this old machine, like I said, there's a metal bracket that holds this in. In the every machine since then, there are 2 screws, pins, threaded pins, that's a good way to put it, that are driven through this metal plate from the other side, and you press this half-moon gasket onto those pins. There are holes in the back of the gasket, make it easy for you to do, and there's a lip on here that you sit within the V groove of the door gasket. The dam gasket fits in the V groove, not behind it, not in front of it, within it. Okay. So water. Water quality is very, very important with sterilizers. You cannot use spring water, mountain water, drinking water, any of those varieties. You should only use distilled water. This says distilled water on it, bought in Walmart. You should never, for any piece of medical equipment that doesn't specifically say it, you should never use deionized water in anything. Deionized water will eke the ions out of the chamber, out of all the copper tubing, out of all the brassware. Eventually your machine will fail and you will wind up replacing a lot. So deionized water, very, very bad. Tap water, never, very, very bad. Distilled water only. Can I? Well, I don't know if I can get the door
I got
open.
a good story for you.
Sure.
So I have a customer, and we had completely refurbished their two M11s. And about 2 weeks later, they were having problems with it, and sure enough, the solenoid that were messed. Everything was messed up because they had looked to me like tap water.
Right, right.
So the girl, the manager goes in, we're talking to the girls that operated, and she's in tears. I swear to you, I used the bottled water that's over on the pallet. And what happened was the company that they bought their water from swapped out.
Ooh, that's sneaky.
And the labels look so much alike, she didn't pay attention to the label.
How about that?
Spring water.
That'll do it every time. They'll do it every time.
But she said, I know I used it right. Well, the company put the wrong water on their pallet near that room.
So I had another about this. I had another argument with somebody the other day about this particular topic. So a guy calls me up and he says, you know, they go to run the machine. Well, he had a problem. We had it in our shop. I brought it to the customer. I run the machine. It works just fine. Customer runs the machine and it's spitting water all over the counter. And he's going, how is that possible? I ran it, worked just fine. These guys run it, spitting water all over the counter. Well, here's what the customer had done. The guy had left the machine with the water at the proper level. It's supposed to be about 1 inch to 1.5 inches below the top of the green. But the technician said, oh, look at that. That's just like halfway up. That doesn't sound right to me. So they filled it up to the very top of the green line. And what happens is when the machine vents back into the reservoir, it dumps all that steam, it bubbles the water in there. The bubbles get transferred out the front of the machine, and the water in this tube literally splattered out and all over their counter. Now, the technician said, that's impossible. My customer wouldn't do that, but I disagree with him. So that please remind your customers only to 1.5 inches, otherwise they get to clean the counter. Yeah. Okay, there is a door switch. There is a little bit of an assembly in this door switch that has a very kind of unusual metal bracket. And on the end of that metal bracket is a tiny, tiny lip. They basically bent it into the bracket. It's about, I think, 1/16 of an inch thick. It's really delicate. It can be broken. If you go to do the door switch, just take a look at that just to be sure it hasn't failed as well. Sometimes it'll do that, and it's really tough to find. Okay, so inside the chamber, part of the annual PM kit again, we have some filters. We don't want all the crud from their packs getting into our nice clean machine. So we want to try to isolate that with these filters. They can be ultrasounded if the machine needs to be cleaned off cycle, but they're basically there to prevent paper or fiber material coming off the packs from getting into the valve streams. As you can see, this is a nice clean chamber wall. This is the water level sensor. We want to make sure this area kind of stays clean because it needs to be conductive between this metal plate and the wall of the chamber. So we want to get off all lime scale and calcium buildup on there. Also, this is a view of our temperature probe, and it has a metal bar sticking into the chamber, and you want that to be clean. You don't want any scale built up on that where it might insulate it and change the temperature that the machine thinks it's seeing. Okay, never scrub the inside of a sterilized chamber with a product that smells like or contains chlorine, end of story. If your customer complains that the door gaskets are pulling out or falling out, 9 times out of 10, they've got some goop on this surface. So get a Scotch-Brite pad, a little bit of water, a little bit of stainless steel cleaner if you need it, polish that off of there, and more times than not, gasket will stop falling out. Now, the other part of the story about door gaskets falling out is all door gaskets are made out of silicon. They are replaced yearly for a reason, because over that year they tend to shrink. There's nothing wrong with a gasket that has shrunken as long as it continues to seal. But if you do find that you've cleaned this surface and the gasket just seems to still be falling out, you let us know. We certainly will be interested in seeing that. That's kind of the reason why Midmark put that wire in their door gasket. They decided that they would solve the problem of shrinking silicon by giving it something to shrink against. Unfortunately, it didn't kind of work that way. Silicon continues to shrink no matter what Midmark thinks. Okay. Yeah, right. So testing biological indicators. Okay. You guys should know about spore tests if you're working on sterilizers. There's a story in spore tests. Wow. I think I guess we've got another couple of minutes. So spore tests. Spore tests do not check the machine. Spore tests are designed to check the operator, though nobody tells the operator that. If you have a failed spore test, don't immediately jump to there's a problem with the machine. Ask the people running the machine how they did the spore test. Is the spore test still active? Is it outdated? Did they put that spore test under a pile of packets right in the middle of a mess? Did they package it in the wrong place? Is it kept from being in the live steam? Before they do anything else, if they had a spore test failure, tell them to run a spore test in an empty chamber. If the spore test fails in an empty chamber, yeah, you got a machine problem. If it passes in an empty chamber, you can say it's an operator problem. That's the biggest problem. Yeah, that's the biggest problem. If you do want to look at the machine to this detail, take a look at the heating element down there. I have seen a failed heating element. It is the ugliest thing you've ever seen. You don't want to have it happen. So if you do see pitting or what look like cracks starting to develop in that heating element, before it fails, please replace it. You don't want to have to go through cleaning the material and that heating element out of every single spot in the sterilizer. It's ugly. Okay, water level sensor, we talked about that before, keep it clean. If your machine, when you go to turn the machine on, if the machine immediately goes from fill to sterilize without waiting for the machine to fill, you've got a shorted water level sensor. The machine already thinks it's full of water. And what's going to happen is it didn't put any water in at all. And in about 5 minutes, it's going to overheat. It's going to give you terrible errors. You're not going to build up any pressure. It's going to be terrible just because that water level sensor already thought there was water in the chamber. Okay. Look for deposit, blah, blah, blah. Temperature sensors, negative coefficient device. You can measure that. In the older machines, the -001 through 19, this is completely wrong. It only applies to the 20 and above. In the 1 through 19s, it's an integrated circuit. You cannot measure it resistively. That gives you any kind of useful information. However, powered, that device will give you a millivolt output that you can actually translate into temperature. So if you really want to go through the details of how to troubleshoot the original temperature probe in the 1 through 19s, it's kind of included in the service literature. It's a little bit hidden, but it's in there. Okay, tech tip for the using of the machine. Come on. There we go. Okay, one of the things you need to be able to do is have sort of an arbitrator on this machine. If you're going to come in and there's going to be a problem, you want to know, is the machine the problem or is there something else going on here? Now, one of the ways that you can do that is by using a thermometer. Now, I'm going to not pass these. They're still a little bit hot, but they'll be up here for anybody that might like to take a look at them. This is a mercury-filled thermometer, just like an old-fashioned fever thermometer that you have to shake down after use. And its purpose is to measure the maximum temperature that the inside of the chamber reached. And once you know the maximum temperature, you can then work through again Boyle's law and determine how much pressure you built up in this machine. And is that error code telling you the truth? Or is there something else going on here? So that's really the best way to tell if you are having a machine, verify machine problem, verify the temperature using one of these lag thermometers. And I'm going to leave them up here. Anybody that would like to take a look at it, feel free. Did I hear somebody say something about part number? RPT113. Yeah. Oh yeah, it's down there too. We're not supposed to talk about part numbers, but there it is. Okay, so this is the technical support that we currently offer. We have information on our website. A copy of the presentation you have just seen with my golden voice is on our website. Y'all can watch it if you have any more questions. It's also, we have technical documentation for our parts, how to put them in, how to take them out. We have all planned maintenance kits, and you have somebody like me. My job at Healthcare Group's RPI is to develop parts. So when we look at a piece of equipment, I'm the guy that figures out what parts we want to come out with. Then I figure out how to come out with them. Then when we sell them, I'm the guy you call when you start having a problem with them because I didn't do them right. And I'm the guy that makes them right the second time. But doesn't happen very often. And we want to be sure that it's right the first time. But I'm the guy that you need to talk to about technical support or any problems or exchanges for parts if you do have a problem with an RPI part. So I get the whole story from beginning to end. I know exactly what happens. One other thing I need to point out is for people who have had experience with Midmark sterilizers already, you may or may not know this. The -01 through 19 and the 20 through 22 printers are no longer available from Midmark. They have never been available from RPI, unfortunately. We've never been able to build them. But I'm happy to say that in about a month, RPI is going to be offering their own data loggers. So you will be able to replace the 001 through 19 printer effectively with a data logger, and we'll be happy to help you with those. That's coming soon. That's kind of everything. We are 5 minutes. That's great. Is there any questions? Anything I can help with? Sir?
I'd like to know a little bit about maybe on duty site, because I had a customer GI lab with 6 rooms. They would run that thing back to back to back. We finally convinced them to get a second one so they could let the first one, because they were calling us like every month. Right. Okay. We actually changed their gaskets quarterly because they asked us to. Mm-hmm. Okay. But they just, is there anything? The other thing too is, it doesn't open far enough, it steams up the keypad, and the next thing you know, you're replacing keypads. That's true, and I can't do anything about that. They built it that way. Thank Midmark for that little stunt. Maybe, but no, it can only move a ½ inch. There's an actual stop to that. It cannot move past the end of this bar. So no matter how many springs you put on it, you're never going to move it up further. Now about duty cycle, if you think about it,
Well, we kind of make it simple. I want to try to keep things simple. So I tell everybody to not run this machine quicker than every 15 minutes, okay? You cannot do back-to-back cycles. Now, there's a reason for that if you kind of think about it. What's happening when you start that machine during that 15 minutes? We're going to go way back here, and we're going to talk about what happens.
Room temperature water.
You're going to be dumping, doesn't matter what temperature water you're going to be dumping, you're going to be dumping water into a hot chamber, and what's going to happen is that water is going to hit the bottom of this chamber that's going to be way over 220, 212 degrees. It's going to immediately turn to steam, and it's going to it's going to mess up the entire system. You want to start with at room temperature or at least warm water. You cannot put hot water, you should not be putting hot water in there, and you should not be putting water in until the chamber is below the boiling point of water so that it's not immediately flashing into steam. That takes about 10 to 15 minutes. So that's the logic behind it. And you can tell them, if they start the machine and the first thing they hear out of this thing is gurgling, that's bad. That's that water hitting the heated bottom, turning into steam, and gurgling back through the fill valve, screwing everything up. Sir?
So maybe I was thinking, isn't that poor sterilization technique as well? Because the packs have to dry. And if they don't have that time, they're going to come out wet and they're not sterilized. So technique is critical. I think if they're concerned about that, I would say you're going to possibly cause infection because they're not sterilized.
One other thing, though, I have to point out to you about that. You are absolutely correct. However, during that dry cycle, you're still heating the chamber. So not only do they have to wait through the dry cycle, they still have to wait the 15 minutes, even if they ran through the entire dry cycle, to let the chamber cool.
Yeah.
That's what I tell them, and it stops that.
Yeah, absolutely. And then it happens a lot, too. Sir?
Yeah, I had a situation like this with Wanda. We had a dental site that had two of them side by side, right against the wall. And right when we picked it up, we're blowing boards, one after another. And I just couldn't, we diagnosed it and couldn't isolate it. Finally, they were running them so much and they were side by side that they were heating up on the board side, and it was just blowing boards. So we had to actually move them, and actually the cooling fan from the back, we had to give them space enough.
Yeah, overheating is not usually the biggest problem. The biggest problem are the relays that are just undersized. But yeah, that not a good situation for them to do that. Another thing that affects these sterilizers, in general, and a lot of other medical equipment, is you can't put one of these on a GFCI. They hate GFCIs. And the reason for that is because of the heating element. A GFCI measures leakage current to ground. And when you have a hot wire going through a ring of grounded metal, you're going to develop leakage. So the older that heating element gets, as it tends to fade over time, it will sag, and it will actually become closer to the wall of that tube that it's in, and that will cause them to give you all kinds of problems with GFCIs.
Concha heater on a respiratory used to do the same thing because of the heating element inside the fluid warmer.
Yeah, like omnibeds or incubators, same problem. Anything that has a heating element to heat water, they don't like GFCIs, hydroculators, anything that uses hot water.
So replacing the heating element cure the GF?
In some cases, yes. In most cases, it doesn't, because there's also leakage that's coming from the board as well as the board tends to age. The best thing is to put it on an outlet that isn't GFCI'd. If they absolutely have to and they're having completely, real big issues, you can buy a line isolation transformer for the machine and it will stop that in its tracks. Oh yeah, easy. No, it's actually not. They are little boxes. They're not terribly expensive, and they're a good solution. And you can do that with a number of different pieces of equipment.
It is code now, plugged into it.
Technically speaking, it's not.
It is a wet location.
Technically speaking, I don't believe that's true.
It depends on what state you're in.
Yeah, and where you're at. Like if you were in a dentist office, not only would they laugh at you, they wouldn't even know what you were just talking about. In a hospital, that is a different situation, yes. And I don't know that it's actually considered a wet location.
How many amps do they normally pull?
12, I want to say 12 in sterilize, maybe like 6 or 8 in dry, because they don't heat. Technically speaking, the way they do the dry, because there's only one heating element, is they do a duty cycle on it. They turn it on for like 15 seconds and turn it off for like 15 seconds and turn it on for 15, turn it off. Any more questions?
How do you like working for the new company?
It's great. It's the best thing ever. I love my new bosses, and my corporate overlords treat me very well. Thank you very much.
That was like a loaded question.
Yeah, especially considering my boss is sitting over there.
The overlord.
The overlords. Yeah, that's right. Performance. And by the way, performance reviews are in November.
For the large steam sterilizers, well, we're already doing it. We've been doing that for years.
Yeah, more.
Oh, yeah.
Love to have more.
Because we still have to go outside.
Yeah.
Well, please tell us what you guys have problems with.
Yeah, I mean, if there are parts that in machines that you folks need parts for specifically, the feedback to Neil and our product development team is critical. So, and really, you know, whatever detail you can give us, install base, number of machines in service in different areas, whatever information you can give us will provide us for additional direction. We have more resources now. We have more product development engineering resources, both in California and in St. Louis, to go after equipment. So
yeah, give us a call. Give me a call. I'm happy to take it. I'm happy to work as an advocate for anybody that's looking to buy some additional parts. Well, that's how we do what we do. We can't do without you guys. Sorry, we had to throw a little bit of a public statement in there, but we're not supposed to talk about businesses. We're supposed to talk about technical stuff. Any more technical questions? Yes, sir.
So somebody already mentioned that the steam can damage the display. Is there any sort of conformal coating process that you can do to help protect it or launch?
I'm glad you asked that question. As a matter of fact, I did that. When I built that little membrane panel on the front there, it has an extra sealant that goes right along the bottom of that. But that should keep it from coming apart. The other thing that you can do now, again, old machine, new machine. Old machine, they actually ran a run of RTV right along here, okay? And you can do that. There's nothing to stop you from doing it. It works perfectly. It's amazing. It keeps steam out completely. I tried to solve it by making this panel more robust. So if it does get steam on it, it won't fail. The display part behind it is already conformally taken care of. It's not the part that's failing. It's the membrane panel on the front of the plastic. And just so, again, now that I've already opened the door to the sales pitch, we now sell these lid panels on the new machines and on the door panels as well. One thing to know about these panels on the older style machine, if your customer says, I keep trying to hit this damn button and nothing is happening, half the time it's not a problem with the panel. The panel on the old machine is mounted behind this piece of plastic, And what happens is over time, the piece of plastic has warped and it's actually moved the panel away from the front of the machine, and the little stem on the button doesn't reach far enough. So they wind up pressing down on it so hard that they crack the overlay, and then they can get it to work because they can get their finger down far enough. You have to replace the cover to solve that. It's not the board itself.